It is an objective method of finding out the error of refraction by utilizing the technique of neutralization. Requirements: a semi-dark room, a trial set, a trial frame, distance vision charts, and retinoscope. With movement. This with movement is neutralized with plus lens. Against movement. This against movement is neutralized with minus lens. No movement. This is the neutralization point. Method: make the patient sit comfortable at a distance of 66 cm from the examiner. You can also use a working distance of 1 meter or 50 cm. Room should be semi-dark. Eye level of both examiner and patient should be on same height. Ask the patient to look at 660 of the type of distance vision chart. Now, with the help of the stick retinoscope, the examiner observes a red reflex into the area of the patient. How to record retinoscopy findings? If our retinoscope light is vertically placed, then we write this neutralized value on the right side of the cross. Here. If our retinoscope light is horizontally placed, then we write this neutralized value on upper side of the cross. Here. How to find axis of both meridian? When you find your meridian to be neutralized, then shrink your retinoscope's light in a fine line by moving retinoscope sleeve, and move the fine line onto the middle of the pupil and note down the value from the trial frame. Here 90 degree. If retinoscope's light is vertically placed, then we write axis value on the top of the cross. Here. Same procedure is applied for the other meridian also. Let's see with the help of animations. Example 1. First of all, see the movement of red reflex with the help of retinoscope. We can see that the red reflex moves with the movement of retinoscope light. As there is a with movement, we add plus lens. Here I am placing plus 2 diopters randomly. Now again move the retinoscope to see the red reflex. Still with movement, the width of red reflex is more. Replace the plus 2 with plus 2.5 diopter. Now again move the retinoscope to see the red reflex. Still with movement, the width of red reflex is more, means approaching towards neutralization point. Replace the 2.5 with plus 3. Now again move the retinoscope to see the red reflex. No movement of red reflex indicates neutralization point of this meridian. This meridian is neutralized by plus 3 lens. Recording findings. Write this neutralized value on right side of the cross. Plus 3 at 180 degree. Now rotate the retinoscope's light perpendicular to the current meridian and keeping a watch on the red reflex. Here I am getting with movement. Now this with movement is neutralized with plus lens. Put plus 1.5 lens randomly. Still with movement, the width of red reflex is more. Remove plus 1.5 lens and put plus 2.5 lens. Still with movement, the width of red reflex is more. Remove plus 2.5 lens and put plus 4. Still with movement the width of red reflex is more. Replace +4 with +4.5. No movement of red reflex indicates neutralization point of this meridian. Write this neutralized value on the top of the cross. Cross representation of values. After doing retinoscopy on both meridians, the cross representation of values are +3 at 180, +4.5 at 90. Subtracting working distance. Here I am doing retinoscopy at 66 cm, so my working distance power will be +1.5 diopter. So I am subtracting +1.5 diopter from the both meridian. Subtracting cycloplegic tonus allowance. After subtracting working distance, the cross values are +3 at 90, +1.5 at 180. Here I am doing dilated retinoscopy under optometry, so my cycloplegic tonus allowance will be +0.5 diopter. So I am subtracting +0.5 diopter sphere from the both meridian. Rough estimation of refractive error. After subtracting working distance and tonus allowance, our cross representation is +2.5 at 90, +1 at 180. Now for a sphere you can take any value from the cross representation. I will take a smaller value for a sphere. Here we take +1 diopter sphere as spherical value. Let's denote our retinoscopy values as A and B. Cylinder power equal to B minus A. The meridian at which our sphere is situated will be our axis of cylinder. Axis equal to 180 degree. Final rough estimation is +1 with +1.5 at 180 degree. Example 2. First of all, see the movement of red reflex with the help of retinoscope. We can see that the red reflex moves against the movement of retinoscope's light. As there is a against movement, we add minus lens. Here I am placing -2 diopter sphere randomly. Now again move the retinoscope to see the red reflex. Still against movement, the width of red reflex is more. Replace the -2 with -2.5. Now again move the retinoscope to see the red reflex. Still against movement, the width of red reflex is more, means approaching towards neutralization point. Replace the -2.5 with -3. Now again move the retinoscope to see the red reflex. No movement of red reflex indicates neutralizing point of this meridian. This meridian is neutralized by -3 diopter sphere. Write this neutralized value on the right side of the cross, -3 at 180. Now rotate the retinoscope slide perpendicular to the current meridian and keeping a watch on the red reflex. Here I am getting with movement. Now this with movement is neutralized with plus lens. Put +1.5 diopter lens. Still with movement, the width of red reflex is more. Remove +1.5 diopter lens and put +2.5. Still with movement, the width of red reflex is more. Remove plus 2.5 lens and put plus 4. Still with movement, the width of red reflex is more. Replace plus 4 with plus 4.5. No movement of red reflex indicates neutralizing point of this meridian. Write this neutralized value on the top of the cross, plus 4.5 at 90. Cross representation of values. After doing retinoscopy on both meridians, the cross representation of values are minus 3 at 180 degree, plus 4.5 at 90 degree. Subtracting working distance. Here I am doing retinoscopy at 66 cm, so my working distance power will be plus 1.5 diopter. So I am subtracting plus 1.5 diopter square from the both meridian. Subtracting cycloplegic tonus allowance. After subtracting working distance, the cross values are plus 3 at 90 degree, minus 4.5 at 180 degree. Here I am doing dilated retinoscopy under hometropine, so my cycloplegic tonus allowance will be plus 0.5. So I am subtracting plus 0.5 from the both meridian. Rough estimation of refractive error. After subtracting working distance and tonus allowance, our cross representation is plus 2.5 at 90, minus 5 at 180 degree. Now for sphere, you can take any value from the cross representation. Ideally we take smaller value for sphere. Here we take plus 2.5 as spherical value. Let's denote our retinoscopy values as A and D. Cylinder equal to A minus B minus 7.5 diopter cylinder. The meridian at which our sphere is situated will be our axis of cylinder. Axis equal to 90. Final rough estimation is plus 2.5 with minus 7.5 at 90 degree. What is the rough estimation of given retinoscopy? Plus 1.5 at 90, plus 2.5 at 180 degree. Kindly write your answer in the comment box. Thank you for watching.